All right, we're back. Video number 2. And this is where it cranks up a notch. This is the new lesson for today. These are the style of problems that'll be on your homework. And these focus in on equations where the angle is not just an x. But you can see from the example on number 1, it's x divided by 4. I think there's another example. Yeah, this one has a 3x. And so all of the same rules that I recapped in video 1 apply, but there's one final thing that we need to do, and it's these 3 steps. And it's if you see an angle that is not just x, we're going to replace that angle with just a big X or like a theta symbol. So I'll kind of do this. I'll solve this first one while we're going through the steps. So the first thing I would do would be to rewrite this problem as the cosine of x equals 0. Okay. I actually like, and I think the book does this, and I think Miss G does this as well. So let's just replace it with a theta symbol. Theta is just a symbol for angle. So cosine of some angle equals 0. Step 2 then is we solve it like normal. So we are going to solve this equation like normal. So when is cosine 0? The answer would be, there are going to be 2 answers again. Cosine is 0 at 90 degrees. And then at the other 90 degree, which is 270. So there are 2 answers. But wait, we're not done, because we just solved cosine of theta equals 0. We didn't solve cosine of x divided by 4 equals 0. So it's a simple fix. The last step is set your answers that we just found equal to the original angle. So for example, I'm going to say x divided by 4 is equal to pi over 2 and 3 pi over 2. So I'm just going to put them next to each other, but you get the idea. So look what we have to do now. We have to solve for x, and that's how we're going to finish this equation. So I need to multiply by 4 to get that to be just x, which means I have to multiply both of my angles by 4. So we're going to actually get 4 pi over 2 as the answer of the first one, and we're going to get 12 pi over 2 as the answer of the second one, and those can reduce down to 4 pi over 2 is 2 pi, and 12 pi over 2 is 6 pi. And this brings us to actually an interesting point, and a very important one. We want, I'm going to put it in a different color, we want to give on these problems all answers that range from 0 to 2 pi. This is what we want the range of our answers to be in. So the fact that 6 pi is out of that range, out of that domain, I should say, the range of the domain. This is our domain for all of our answers that we want to include. So you can see that this one works, but 6 pi is not included in that domain, so we're not going to count it. So actually the only answer that I would want you to put down for this equation is 2 pi. And I am not going to do this for every problem, but as you can see, if we put 2 pi in for x, look what we get. 2 pi over 4 equals 0. 2 pi over 4 reduces down to pi over 2, which we just said is 0. So the answer does check. And so how do I want to sum this up? I guess here's my summary before we do a harder example, is that I'm going to actually, this is going to be great. Let me show you something on Desmos here. This is just a normal sine wave graph. And I think you know from Algebra 2 and college algebra that when you're solving for x in an equation, the solutions are the x-intercepts. So as you can see, there are 3 different solutions for when x is equal to 0 for a sine wave. There are the 3. And notice there are there's a never-ending amount. But for the sake of efficiency, we're only going to give the answers that range from 0 to 2 pi. So there are 3. But look what happens if I graph sine of 3x. How many answers do you see now? We see 1, 2, 3, 4, 5, 6, 7 answers within the same 0 to 2 pi domain. So some problems, if they have a 3x, will have far more answers than 2. Other problems, let's turn that one off. Let's do one that's going to have less answers. Let's do a 1/4, just like in the example. Sine of 1/4. Desmos doesn't like that. X. Whoops, I need to put the x inside there. My bad. Look at that. This is so stretched out that it's going to have less answers than a normal. I just use 0.5. There you go. You can see there's 2 answers. So depending on the period of the graph, the amount of answers is going to change. And that's the point that I was trying to get to. And I'm going to write that, I think, here in maybe blue. Actually, let's do it up at the top because it matters. The period of sine, cosine, cosecant, and secant, they all have period of 2 pi. Okay, and tangent and cotangent have a period of pi. And so in order to find your period for a specific equation, we'll use 2 pi divided by b, and we'll use pi divided by b. And here's why that matters. And you'll see it on the next example is sometimes we will only get 2 answers when we solve the equation, but there might be a lot more before we get to 2 pi. And in order to find every solution, we have to add the period on to each one of our solutions. I know that sounds confusing. Let me make it a reality here, and we'll tie it up and wrap up this video with our final example. So tangent squared 3x equals 3. We look at our steps. What do we do first? We need to replace the angle with like a theta symbol. So I'm going to say tangent squared theta equals 3. And I'm going to solve it this way. So tangent squared, we need to square root both sides. So tangent of theta equals plus or minus the square root of 3. And this is going to find, I'm going to find 4 answers here. But I'm not going to be even close to done. So pay close attention. The 4 different answers that make this equation true. When is tangent the square root of 3? That is at 60 degrees. So it's going to be all the pi over 3's. And the reason it's all of them is because of the plus and the minus. So I need all 4 quadrants. So got pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. But then we have to take each of those and set it equal to the original angle, which was 3x. So it's actually 3x equals all of these things. So I'm actually going to just, to save myself some room, put it here. Yikes. So what do I need to do? I need to now divide by 3, which would then divide all 4 of my answers by 3. So my answers are going to be, whenever you divide it by 3, that's just going to become a 9. So notice, I'm dividing these, whoops, and they're all becoming a lot smaller. 4 pi over 9, 5 pi over 9. And so check this out. These 4 answers went from 1/3 to 5/3. It almost went to 2 pi. But look at this. This stops at 5 pi over 9. That's still not even to 1 pi. So there are a lot more answers that we need to add on to this. So here's how you do it. You go and find the period. And the key is to add the period to each of your answers. until you reach 2 pi. Once you reach 2 pi, you stop. So I'm going to stay in red. I'm going to go up here, and I see that it's a tangent graph of 3x. So I need to find the period. So I'm going to do pi over b. Remember, with tangent, it's pi over b. So that is my period. So I'm going to add pi over 3 to this, and to this, and to this, and to this. And I might even need to keep going until I reach 2 pi. So let me just, to make my math easier, convert this to have a common denominator of 9 on the bottom. So I'm going to be adding 3 pi over 9 to all of my answers. I'm going to stay in red so that you can see the added answers are separate from the original 4. Pi over 9 plus 3 pi over 9 is 4 pi over 9. We'll already have one of those, so I'm not going to put it twice. 2 pi over 9 plus 3 pi over 9 is 5. I already have one of those. But when I do 4 pi over 9 times 3 pi over 9, that makes 7. Don't have one of those. 3 pi over 9 times 5, that's going to be 8 pi over 9. And then I keep going. Now I add it to this, which makes 10 pi over 9. Now I add it to this, which makes 11 pi over 9. Now you can see we're at least over 1 pi, but we're far from 2 pi. So then I keep going. 14 pi, 3 pi over 9 plus that. Oh, I skipped one. 3 pi over 9 plus 10 actually makes 13 pi over 9. 3 pi over 9 plus 11 makes 14. Then I've got to keep adding it. I think we're almost done. So we're going to have 16 pi over 9. And then we're going to have 17 pi over 9. And that is it, because that is awfully close to 2 pi. So those are all of our solutions. This is nuts, right? But it makes sense because trig functions are periodic. They go forever. And so when it's really, really smushed in, you're going to have a lot more solutions. So how many do we have? 1, 2, 3, 4, 5, 6, 7, 8. 12 solutions. Wowzers. And that's only 12 solutions from the 0 to 2 pi. There's obviously infinite amount of solutions. So in summary, before we close this video down, and then you can try some of the homework. The first step that you need to master, don't worry about getting all the solutions yet. First thing to master is how you replace the angle with a 0, you solve to get your solutions, and then you set it equal to the original angle to find your more accurate solutions. But in those particular graphs where you realize, like, wait a minute, I'm circling it down here in red, wait a minute, that's not all the way to 2 pi. I need to add some solutions. The key is to add the period to your solutions until you can finish your list of solutions. So I encourage you to try some examples on your own, work with those around you, and finish the assignment in class so that you do not have homework. Use your neighbors. If there's a math teacher in there that's subbing, maybe ask them for help. But I think this video and your partners are your best options. Good luck. Star any questions that come up, and I will help you when I get back. Have a great weekend. I'll stop this thing.